When installing 600-volt cables, specifically those that are 4/0 American wire gauge or larger, in cable trays, a crucial aspect to consider is the cable fill capacity. The National Electrical Code, or NEC, dictates a maximum fill percentage to ensure proper heat dissipation, prevent cable damage, and maintain overall electrical safety. For these larger 600-volt cables and cable trays, the NEC specifies a maximum random fill of 33%. This means that the total cross-sectional area of all cables within the tray should not exceed 33% of the tray's cross-sectional area. Understanding and adhering to this 33% fill rule is vital for several reasons. Firstly, it directly impacts the ampacity, or current carrying capacity, of the cables. When cables are packed too tightly, they generate more heat due to the increased conductor resistance. This heat can degrade the insulation, leading to premature cable failure and potential electrical hazards. The 33% fill limit allows for adequate air circulation around the cables, facilitating heat dissipation and ensuring that the cables operate within their rated temperature limits. Secondly, exceeding the fill capacity can make it difficult to properly manage and maintain the cables. Overcrowded trays can hinder the ability to inspect, test, and replace cables when necessary. This can lead to increased downtime and higher maintenance costs. Thirdly, adhering to the fill requirements helps prevent physical damage to the cables. When cables are crammed into a tray, they can be subjected to excessive bending, pulling, and abrasion. This can compromise the integrity of the insulation and conductors, increasing the risk of shorts, grounds, and other electrical faults. To accurately calculate the cable fill in a tray, you need to determine the cross-sectional area of each cable. Cable manufacturers typically provide this information in their product specifications. For circular cables, the area can be calculated using the formula pi times the radius squared, where the radius is half of the cable's diameter. For cables with non-circular cross-sections, the manufacturer's specifications will provide the area directly. Once you have the cross-sectional area of each cable, you can sum them up to find the total cable area within the tray. Then, you need to determine the usable cross-sectional area of the cable tray itself. This is typically the area between the side rails of the tray, excluding any obstructions or supports. The tray manufacturer's specifications will provide this information. To determine if the cable fill is within the 33% limit, divide the total cable area by the tray area and multiply by 100. If the result is less than or equal to 33%, then the cable fill is compliant. If it exceeds 33%, you need to reduce the number of cables or use a larger cable tray. There are several strategies you can use to optimize cable fill in trays. Firstly, consider using cables with smaller diameters. While maintaining the required ampacity, selecting cables with compact designs can significantly reduce the overall cable area. Secondly, properly route and organize the cables within the tray. Avoid unnecessary bends and crossovers, and ensure that the cables are evenly distributed across the tray's width. Thirdly, use cable ties or other accessories to bundle and secure the cables. This can help prevent them from shifting and overlapping, maximizing the available space. Fourthly, consider using cable trays with built-in dividers or separators. These can help organize the cables and prevent them from interfering with each other. In addition to the 33% fill limit for random fill, the NEC also specifies fill requirements for cable trays that are filled with a single layer of cables. In this case, the sum of the diameters of all cables in the tray must not exceed the width of the cable tray. This requirement ensures that the cables are evenly distributed and that there is adequate space for heat dissipation. It's important to note that these fill requirements are based on the NEC and may vary depending on local codes and regulations. Always consult with a qualified electrical inspector or engineer to ensure compliance with all applicable requirements. In addition to the NEC, other standards and guidelines may also apply to cable tray installations. For example, the National Electrical Manufacturers Association, or NEMA, publishes standards for cable trays that specify their load carrying capacity, corrosion resistance, and other performance characteristics. These standards can be helpful in selecting the appropriate cable tray for a particular application. Furthermore, proper grounding and bonding of cable trays is essential for electrical safety. The NEC requires that cable trays be grounded and bonded to provide a low impedance path for fault currents. This helps to prevent electrical shock hazards and equipment damage. The grounding and bonding requirements vary depending on the type of cable tray and the application. Always follow the manufacturer's instructions and consult with a qualified electrical professional to ensure proper grounding and bonding. When installing cables and cable trays, it's also important to protect them from physical damage. This can be achieved by using cable tray covers or other protective measures. Cable tray covers can help protect the cables from falling objects, weather exposure, and other hazards. In addition, consider using strain relief devices to prevent excessive stress on the cable terminations. Strain relief devices can help prevent cable pullout and ensure a reliable electrical connection. Proper labeling of cables is also essential for cable tray installations. Cables should be clearly labeled with their voltage, opacity, and circuit identification. This makes it easier to identify and troubleshoot cables during maintenance and repair. Use durable and weather-resistant labels that will withstand the harsh conditions of the cable tray environment. Finally, regular inspection and maintenance of cable trays are important for ensuring their continued reliability and safety. Inspect the cable trays for any signs of damage, corrosion, or loose connections. Tighten any loose connections and replace any damaged components. Clean the cable trays regularly to remove any dust, dirt, or debris. This will help to maintain proper heat dissipation and prevent electrical hazards. Remember, adhering to the 33% fill requirement for 600-volt cables and cable trays is crucial for ensuring electrical safety, reliability, and maintainability. Always consult with qualified electrical professionals and follow all applicable codes and standards to ensure a safe and compliant installation. The 33% fill rule is not just a suggestion, but a critical safety measure. Overfilling cable trays can lead to overheating, insulation breakdown, and potentially dangerous electrical faults. By adhering to this guideline, you are contributing to a safer and more reliable electrical system. Keep in mind that the type of cable also affects the fill calculations. Some cables are naturally larger than others for the same ampacity rating. For example, a cable with thicker insulation may have a larger overall diameter, even though it carries the same current as a cable with thinner insulation. Always refer to the cable manufacturer's specifications for the exact dimensions of each cable. Also, consider the future needs of the electrical system. If there is a possibility that additional cables will be added to the cable tray in the future, it's wise to leave some extra space. This will avoid the need to replace the cable tray with a larger one later on. When calculating cable fill, be sure to account for any splices or terminations within the cable tray. Splices and terminations can significantly increase the overall cable area, so it's important to include them in the calculations. Consider using splice kit or termination methods that minimize the overall size of the connection. Finally, remember that the 33% fill rule is just one aspect of a safe and reliable cable tray installation. Proper grounding, bonding, support, and protection are also essential. Always follow all applicable codes and standards and consult with qualified electrical professionals to ensure a safe and compliant installation. It is important to consider the environmental conditions where the cable tray is installed. In areas with high temperatures, it may be necessary to direct the ampacity of the cables or use a larger cable tray to ensure adequate heat dissipation. In corrosive environments, use cable trays and cables that are specifically designed for those conditions. The type of cable tray material also affects its performance. Aluminum cable trays are lightweight and corrosion resistant, while steel cable trays are stronger and more durable. Choose the cable tray material that is best suited for the specific application. Also, consider the accessibility of the cable tray. Ensure that the cable tray is easily accessible for inspection, maintenance, and repairs. Provide adequate clearance around the cable tray for personnel to work safely. Use appropriate tools and equipment when installing and maintaining cable trays. Follow the manufacturer's instructions and safety guidelines. Never overload cable trays or use them for purposes for which they are not intended. This can lead to structural failure and electrical hazards. When working with electrical cables, always energize the circuit before performing any work. Use appropriate personal protective equipment, such as gloves and safety glasses. Follow lockout/tagout procedures to prevent accidental energization of the circuit. Be aware of the potential hazards associated with cable tray installations, such as electrical shock, falls, and cuts. Take precautions to minimize these risks. And remember, safety is always the top priority. Never compromise safety for the sake of speed or convenience. If you are unsure about any aspect of cable tray installation, consult with a qualified electrical professional. They can provide guidance and assistance to ensure a safe and compliant installation. In summary, the 33% fill rule for 600-volt 4/0 or larger cables in cable trays is a critical safety requirement. By understanding and adhering to this guideline, you can help to ensure a safe, reliable, and maintainable electrical system.